Well, how many of you can remember what it was like back in the junior high school days? For a great many of us, it was the ultimate time of comparing oneself with everyone else. Am I good enough? Do I measure up? How am I compared to someone else? And it is oftentimes the case, though not always, that we find ourselves on the short end of the stick when we compare ourselves to someone else. And it is not a wise position to be in, but it is a very common position that many find themselves in. Sometimes you grow out of it, sometimes you don't. And there were two men that recognized this anomaly, and they began a series of books called Such and Such for Dummies. John Kilcucken and Dan Gukin recognized this, and out of their brilliance began a series for those of us that feel like we are on the dummy side of the scale. When I built my first web page, one of the books that I bought was Building Web Pages for Dummies. And much later, when I had an interest in learning the Hebrew language, one of the books I picked up was Hebrew for Dummies. There is a book for dummies on just about every topic there is out there. And that's somewhat the title of this video is going to be, Compound Angles for Dummies. Well, as you've been following along, you know I'm in the process of building these two Yellowstone Park stagecoaches, and I'm at the point now of where I am putting the seat arms and the seat backs onto these seat bases, and there are a bunch of compound angles involved. And as you remember here a few videos back, I put out a request to you brainiacs compared to us pea-brains. See, there's the comparison issue still going on, and I'm 71 years old. But I asked, what is the equation if I change the angle of the arm or the seat back on any of these seat angles? What is the relationship or the formula to how it affects all the other angles? And some of you sent some of those answers. Most of them through email, because it gets to be a long, complicated answer, and it's too long for the comment section. And where I had asked a high school teacher here locally what that formula was, and he came back and said, I don't know. Well, with your answers that you have been sending, I began to realize it is not an algebraic formula. It is a trigonometric formula. And that took me back in my memory to high school. In my senior year, I took a class on trigonometry. Not a lot of it sunk in real well. And then my freshman year in college, I also took another class on trigonometry. And this brings up the point that knowledge plus understanding equals wisdom. Well, I was gaining some knowledge of how trigonometry worked, I think, limited as it was, but I didn't have much understanding because I didn't have any application for that. So therefore, the wisdom in using that was lacking in my case. And so now, all these years later, over 50 years later, I'm beginning to have one of these light bulb moments that, oh, now I understand that's the purpose of trigonometry. When you're taking three different planes on three different angles and you're changing all these angles, how does all that work? Well, this brings up sine, cosine, secant, cosecant, tangent, cotangent, all these things that have been back in my forgotten memory of, oh, trigonometry, that's where the formula lies. I need a book for dummies. Well, I think I've shared in the past that I did go to college and I got a degree in agricultural business. I wasn't so much interested in the business aspect of it as I was interested in agriculture. Now, I was not raised on a farm or ranch. My folks had 10 acres and we grew up around horses and cows and chickens, and we always had these animals around. But I had always kind of desired or wished that I had been raised in a ranch environment. Well, I had a good friend from eastern Montana who was raised off of the ranch. Eastern Montana is big ranch country. And I was sharing with him, Dale was his name, about some of my disappointments of, I just don't have that background. I wish I had that, because that's really where my heart's desire is, to be involved in agriculture. And he, having come in off of the ranch, was kind of going the different direction. He wanted something other than what was normal to him, the ranching lifestyle. And here I was looking for it. Again, this comparison issue. And he shared a statement with me that has stuck ever since. And he said, there was a saying by Will James that said, "We're all ignorant, just happens to be in different areas." He was ignorant, he felt, in the life off of the farm. I felt like I was ignorant of the life on the farm. So when some of you started sending these equations saying, "Here's your answer," I started feeling like I'm maybe kind of pretty ignorant. But you talk a lingo because you have the knowledge and you have the understanding, and therefore you are able to apply this with wisdom in the area of your expertise, whether it is in mechanical engineering, or perhaps it is in surveying, or some of you are in oceanography, some of you perhaps are mariners because you use it to navigate by the stars. And you talk this lingo that comes very natural to you, that some of it is not so natural to us because we don't have that wisdom going back to the basis of knowledge and understanding. When I start throwing around the language of 4/4, 5/4, 6/4, 8/4, 10/4, 12/4, some of you are going, "What? Why don't you just say inch, inch and a quarter, inch and a half, 2, 3, 4 inch?" And then we all would just know what you're talking about. Well, this goes back to the foundation of what we learned in school. Generally, you take a fraction and you reduce it to the lowest common denominator. So a 4/4 would be 1, a 5/4 would be 1 1/4, and it goes all the way up into 16/4. If you were to reduce that down, you'd have 4 inch. Why don't you just call it 4 inch? Well, that's just not the lingo when you're talking about hardwoods. And if you're in the construction business, and especially maybe a roofer, you're talking about slopes on a roof. You have a 1/12, a 3/12, a 6/12, a 4/12, a 8/12. What does all that stuff mean? Well, it has to do with the lingo of construction. A 1/12 is 1 foot rise for every 12 foot of run. I went and ordered the tin for my calf shed, and this was kind of comical. He asked me, "Well, what kind of pitch do you have on your roof?" I said, "Well, I raise 2 feet in every 8 feet. He says, "Oh, well, you have a 3/12 pitch." I said, "No, I have a 1/4 pitch." Playing with him. But that's the lingo. They're both the same thing. 1/4 is the same as 3/12. But the lingo becomes 3/12, 4/12, 6/12. A 12/12 is a 45-degree angle. 12 foot of rise over 12 foot of run, you have a 45-degree angle. That's a pretty steep roof. And it's that way in agriculture as well. When I began being in the livestock circles, I go into a auction and they'll talk about 3 weights, 4 weights, 5 weights. What are they talking about? Well, they're talking about whether they're 300-pound range or the 400-pound range, and it goes from 400 to 500 or 499. And if they get to 500 to just shy of 600, then they're 5 weights. So that you begin to learn the lingo of whatever you're in. And that's part of the deal with this trigonometry deal as well. When you start talking about trigonometric functions, cosines over the cosines over the inverse and the first quadrant and the second quadrant, you're just talking a different language that the rest of us maybe are not all that familiar with. And this kind of ties into some conversations that I've had this summer with some visitors, especially those of you who have come from overseas. We've had you from the Netherlands, from France, just all over. It's been pretty amazing. But one of the conversations that came up was over the nomenclature that I use when I measure. I'm using the Dewey Decimal System, and most of the world is on a metric system. So this particular lady says, when you start talking about 30 seconds and 64ths and 16ths, It's like you're speaking Chinese to me. I don't have a clue what you're talking about. Well, the flip side of that coin is I am very unfamiliar with the metric system because that's just the application of what we have learned, what I have learned. All of these vehicles in the carriage trade were built on the decimal system. And so for me to convert that over into a metric system would be a real challenge because that's not how they were built. And that's not really what I learned. I have studied some, and I do use some of the metric system, basically because I drive cars that are predominantly metric. So I've had to learn what a 9mm is, which is very seldom, 8s and 10s and all that type of stuff. But it's out of necessity, it's not out of desire. So similar type thing when we talk our own lingo, someone that doesn't have that understanding sounds like Chinese. And sometimes a little bit of this trigonometry sounds a bit like Chinese. And so the bottom line of all this is, can I accomplish compound angles on a seat like this without trigonometry? Or do I have to go through this calculation every time to get these angles just right? Well, I think there is a way that you can do compound angles for dummies. So in this case, I'm wanting to find out what the angles are for this old Yellowstone Park coach. Say I'd never done it before. How do I figure out what all these are? Well, as the seat back and the arm are on the frame, I could take and find that angle and then take an protractor, angle finder, whatever it is, and find out what that angle needs to be. That would be the best way to do it. In this case, I want the arms to be at a 26 degree and the rear back of the seat is 34 degrees. Those are the angles that I'm using for the coach that I'm working on. So that's my foundation starting point. And the other observation is that we want these to come in at a square 90 degrees this direction. So I've started out with my basics here. This piece here I have cut square, and it's going to simulate the base of my seat. And I have two boards here that I've cut bevels on. This one is at 34 degrees. This is going to be the back. And this one I have cut at 26 degrees. This is going to be the arm. And they need to fit up on this base that is square. So the question is, what are the angles I need to cut these to get them to come together? In this case, the arm is going to come past and the seat base is going to butt up to the arm. So I am going to bring my fence forward so that I have something to push my base against. Now if you have two people and an extra set of hands, it makes this easier. But this is on a triangle, so the long side is going to be the side that my back will sit on. The short side will be the side where my arm will be. So I'm going to find where that sets on that bevel. Another option is actually to take these, like I showed in a previous video, and actually screw these into place on that base to help you hold that as well, doing it by yourself. So as I hold those in position, this is where I can push up against my fence to hold that steady where both are going to be. And take my pencil here. That's going to become the angle for the back of my seat arm. So I just need to reposition this. My left hand is the seat back. This is the seat arm. I'm going to hold those both where they are setting on the base where that bevel is going to be. That is going to be the bevel that will come in and intersect with the seat arm, and it's going to set inside. So that gives me these two angle measurements, but these are not cut at a 90 degrees, remember. So now this is my seat back, and that's the angle there of the cut that goes to the arm. So I take my protractor, my angle finder, line that up there, and I am at 1022. So this angle here is at a 22 degree. And if I do the same on the seat arm, right there, I am at a 10, 20, 30. So this angle here becomes a 30 degree. So how does that line up with the pattern I had already drawn out? This is the pattern for my seat arm, and I have that calculated as 30 degrees also. And this is my seat back. You see I had that calculated at 22 degrees also. So that matches up with my patterns. No calculations. So I'm going to set my chop saw because it's quicker than setting up my table saw. And I'm going to take a 30 degree here since these are scraps, and I'm going to cut this at 30 degrees, and I'll cut this at 22. And I had this already set at a bevel before, but I don't want that now. I'm going to set it at square. And this one I have set at 22. This will be for the back. And I want this set at 30. Right there. So there's my 22 and my 30, but we're still at a 90. So I clamped my seat base down to hold it in position. This is the back, this is the arm. So the back is going to butt into the arm, holding these square, holding these at the bevel, and you can see how the 90 degree cut is not correct. If we actually put these together at that joint, then we lose our 90 degrees down here in the corner. So, again, just using my pencil as a guideline, that is the angle that the seat back has to hit the seat arm. And if I use my angle gauge here, short distance becomes a little more difficult, but right there I have, there's 10, I show 14 degrees right there. I remember from my pattern I have 15, right there I'm at 15. You can't hardly tell the difference there. Could very well be 15. Those that have done the trigonometry calculations say this actually should be a 16. But that's what I have on my angles here as well. I have calculated at 15. So what about the end of the arm here? That should be correlative the same. It should also be at the 15 degrees. So this is my 30 degree on the arm. When you come up to an angle this direction, the bevel will go that direction. So I need to bring my blade this way 15 degrees. There's 15. I'm still set at 30 here, but now my 15 will be the correct direction that way. And that gives me my bevel on the angle. I'll do the same for the 22 degrees. Come up this way, my angle should go this way. There's 22. My blade is still set this direction. I can take that cut. So again, my seat back, my seat arm. I now have a joint that is square in the corner down here, and it fits up here. And if I did it this other direction, I'd push my fence out of the way because my arm is a little extra long. We're sitting right there, so I have a nice joint here. And you can see we're right in line with this face here on the back bevel of the seat angle. So we have both of these corners cut correctly. We have a square in the corner on our frame and a joint that fits nice. So a 30 on the inside, 14, 22, and 14 gives us a nice cut and no trigonometry. And you can go back and do this for any combination that you want. I have one marked here for a Democrat seat that we have a 20 degree angle. This one actually comes in at a 45 in the corner. So these angles here are actually 41.5. These angles that they set out is 20. So this is just a reminder of how a Democrat seat fits. I have a farm wagon or a spring wagon seat back. This is the arm, this is the back. Again, similar type deal. Figure out which direction what goes where. So anyway, no matter what the angles are, this is a 20, this is a 25. You can do the same thing by mocking it up and doing what I just showed you. This is an international seat. The arm is at 20 degrees, the seat back is at 18 degrees. So we have an 18 degree here, 7 degree there, 19 degree there, 7 degree there. So you see how this all fits together no matter what combination you have. It's just using a test piece and mocking it up just like I've done here and getting the angles you need just by finding the relationship to each other. So for me, it seems like this is a pretty simple approach. Therefore, it's in the category of compound angles for dummies, which I fit right into. But it's easy to figure out these angles without any calculations. I do appreciate all the input on go to this chart, go to that chart, ask the AI. Somebody typed in this question to AI and they said it took them 5 minutes to come up with the answer. And it's quite a complicated answer. And it ended up in an Excel spreadsheet with all these calculations into it. Anyway, I think this works pretty simply. Now, can you prove it through trigonometry? Absolutely. And if your tendency to do that, have at her. But if you're just a wood butcher like I am, this is a pretty good way to figure out the angles, and it's pretty accurate, and it works. Anyway, I hope this all helps. Calculating compound angles for dummies. Appreciate you coming along. Thanks for watching.